Okay, so today in our discussion, we are going to discuss about inverse distance weighting method. Screen is visible.
Yes, sir.
Okay, so as you know, in the previous session, we learned about or we get a brief about many different methods of interpolation, right? And inverse distance weighting is one of them. So first of all, let us do a quick recap. What is interpolation? Interpolation is the process of estimating unknown values that fall between known values, right? So you when you want to find out a value at a point which is not known, right? If you want to find out a value of some variable that is unknown with the help of uh, with the help of values at the variable at the neighboring points or some other points, then the method is known as interpolation, है ना? कि आप किसी एक लोकेशन पे आप किसी एक वेरिएबल की वैल्यू फाइंड आउट करना चाह रहे हैं. वेरिएबल कुड बी एनीथिंग, टेम्परेचर, रेनफॉल, कुछ कुछ भी. उसके आप वैल्यू किसी एक पॉइंट पे निकालना चाह रहे हैं जहाँ पे उसके आपका डाटा नहीं है, यू डू नॉट हैव वैल्यू, बट उसके आसपास के पॉइंट्स पे आपके पास यू डू हैव वैल्यू और डाटा अवेलेबल. सो बाय यूजिंग दैट डाटा, है ना, आप उसके बीच का जो पॉइंट है, जो अननोन पॉइंट है, वहां पे जो वैल्यू निकालोगे, दैट मेथड इज नोन एज योर इंटरपोलेशन. Okay, so in this example, a straight line passes through uh, 2 points of known value. You can estimate the point of a known value because it appears to be midway between the other 2 points. The interpolated value of the midway point could be 9.5, right? So यहाँ पर आप जो the red dot or the red point shown in this diagram is your the point where you want to find out the unknown value, है ना, जहाँ पे आपके पास वैल्यू नोन नहीं है, यहाँ पे आप निकालना चाह रहे हो, बट यू हैव known values at जहाँ पे एट टू नेबरिंग पॉइंट्स, है ना, किसी टू नेबरिंग पॉइंट्स पे आपकी वैल्यूज नोन है. एक जगह पे 9 वैल्यू और एक जगह पे 10 वैल्यू है. सो यू कैन से दैट इट इज lying in midway between those 2 points, so its value could be 9.5. बट मोर एक्यूरेटली, इफ यू वांट टू फाइंड आउट मोर एक्यूरेटली, तो आपको कैसे निकालना पड़ेगा? आप अलग अलग तरीकों से आप यहाँ पर लाइन की इक्वेशन निकाल सकते हैं, क्योंकि आपको पता है कि ये रेड जो डॉट है, अननोन वेरिएबल जो है, वहाँ पर वो इस लाइन पे फॉलो कर रहा है. तो आप इस लाइन की ओके, सो by using the information or the values at these 2 points, the 2 points that are represented by the black dots, you can find out the value at the unknown. You can find out the value at the point where the value was not known. That is the red point. यहाँ पर आपकी value क्या थी? Unknown, right? So this is your interpolation. So your interpolation is used to create surfaces, that is the raster surfaces, for example elevation, rainfall, temperature, chemical dispersion or other spatially based phenomena, है ना. तो आपका where do you use interpolation in spatial technologies? To generate a surface, है ना. आपके पास जो डाटा होगा वो स्पेसिफिक लोकेशंस पे होगा, यानी कि पॉइंट डाटा. यू विल हैव डाटा that is point data, but using those point data that is dispersed, you can find out the values in between and you can generate whole surface. आप पूरे surface के लिए, आप पूरे area के लिए आप value निकाल सकते हो. So you can generate a interpolated surface by using the point data, right? तो जैसे कि एलिवेशन, आप डिफरेंट डिफरेंट पॉइंट्स पे आपने एलिवेशन निकाला हुआ है आपके पास डाटा एलिवेशन का या रेनफॉल का, डिफरेंट डिफरेंट जो स्टेशन है वहाँ पर आपके पास रेनफॉल का डाटा है, बट यू वांट टू फाइंड आउट द डिस्ट्रीब्यूशन ऑफ रेनफॉल अक्रॉस द रीजन, देन व्हाट यू विल हैव टू डू, आपके पास जो डाटा है वो तो स्टेशन से मिलेगा, स्टेशन तो पॉइंट डाटा प्रोवाइड करेगा आपको किसी एक स्पेसिफिक पॉइंट पे, लोकेशन पे। सो बट आपने पूरे रीजन के लिए वो बट यू वांट टू determine the distribution of the rainfall in the whole region, then you will perform the interpolation method, right? And the output of the interpolation is going to be the raster. Most frequently it is going to be raster. Then a triangular irregular network can also be the output sometimes in your spatial technologies in GIS and etc. Okay, then many interpolation methods are there, as already discussed in previous lecture, like your inverse distance weighted method, spline method, nearest neighborhood, bringing, spatial moving average, right? Thiesen polygon. These all are different types of interpolation method, and uh, and these interpolation can be classified into two categories, like your local as well as global, and other is uh, absolute and exact. Okay, absolute और exact में क्या है, in the sorry, not absolute and exact but exact and approximate. In the exact interpolation methods what happen, that the surface that you are generating है ना, जो आप interpolation surface जो आप generate करेंगे, that is going to pass through all the points, that is your exact method. And in your approximation method, the surface that you are generating is not going to pass through all the points, right? it will uh, it will be representing the points, the input points, but it will not pass exactly through all of them in your approximate method, right? So why should we do the interpolation? Because it is more realistic representation of a geographic phenomena, like आप पे जो your rainfall, your temperature, these are not some point phenomena, right? These rainfall or temperature or elevation, these are distributed spatially, right? At different point in different location they have different values. और ये इस तरीके, ये जो आपके फिनोमेना है जैसे कि रेनफॉल हो गया, योर एलिवेशन, टेक योर टेम्परेचर, ये ऐसा तो है नहीं कि किसी एक पॉइंट पॉइंट पे होंगे और बीच में कोई टेम्परेचर नहीं होगा, बीच में कोई एलिवेशन नहीं होगा. these are these are distributed spatially continuously. This is a continuous data, right? So to represent it more accurately, you will have to perform, or you will have to use interpolation, राइट? आपका पॉइंट डाटा इतनी अच्छी तरीके से उसको रिप्रेजेंट नहीं कर पाएगा, बिकॉज पॉइंट डाटा तो जस्ट स्पेसिफिक लोकेशंस पर वैल्यू है, बट ये जो फिनोमिना, दीज आर कंटिन्यूअस फिनोमिना, कंटिन्यूअस डिस्ट्रीब्यूटेड कंटिन्यूअसली in a space, right? So we have to use, or we have to generate the interpolation surface using the interpolation methods. And point data or measurements may be all that you can obtain, right? आप आप हर एक पॉइंट पे आप डाटा नहीं ऑब्टेन कर सकते. आप जो डाटा ऑब्टेन कर पाएंगे, दैट इज गोइंग टू बी योर पॉइंट डाटा. कुछ कुछ स्टेशन पर आप हर एक पॉइंट पे, मतलब कि कंटिन्यूस डाटा आप ऐसे ऑब्टेन नहीं कर सकते कि हर एक पॉइंट पे आप डाटा ऑब्टेन कर पाए. यू कैन ओनली ऑब्टेन डाटा at specific location and at specific stations, so that is going to be your point data. But you want to represent a spatial continuous phenomena, then you will have to use the interpolation method. Okay, and it is less expensive to collect, है ना. आप just you just collect the data, or you make measurement at some selected points, and for the rest of the space or for the rest of the region you can calculate the value by using the interpolation method, है ना. तो आपको बहुत सारे पॉइंट्स पे, मतलब हर एक जगह आपको डाटा लेने की जरूरत नहीं पड़ेगी. You just take the measurement at some specific location. For the rest of the region you can uh, find out the value by interpolating. So that is why interpolation should be done. या एंड इट इज़ नॉट पॉसिबल टू मेजर द इन्फिनेटली स्मॉल यूनिट्स, है ना, कि बहुत छोटे छोटे आप हर एक जगह पे, वही वाली बात आ गई कि आप बहुत पास पास भी आप डाटा कलेक्ट नहीं कर सकते, दैट विल बी वेरी एक्सपेंसिव। तो आपको डाटा तो दूर दूर और पॉइंट्स में कलेक्ट करना पड़ेगा। सो एंड टू मेक इट कंटिन्यूअस वी हैव टू use interpolation method. Okay, so what happens in interpolation? Suppose in specifically raster interpolation, in GIS specifically. So you have point data set of known rainfall level values. We here are taking the example of rainfall values. Suppose we have data of point data or station data of rainfall values spread or distributed in a region, you know. So the number that you are seeing here are representing the amount of rainfall at those particular rainfall station, you know. So but you have to represent the rainfall, but you have to find out the rainfall for whole of the region, not for the selected points, but whole of the region. Then, as we know, we have to perform the interpolation. We have to adopt the interpolation technique, right? So here unknown values are estimated with a mathematical formula that uses the value of nearby known points. So यहाँ पे आपके लेफ्ट साइड में जो आपकी पिक है, वहाँ पे जो आपके ब्लैक पॉइंट्स हैं, ब्लैक डॉट हैं, वहाँ उनके साथ एनोटेशन भी है, नंबर दिए गए हैं। वो नंबर क्या बता रहे हैं आपको कि रेनफॉल का अमाउंट कितना है उस पर्टिकुलर स्टेशन पे। हमारे पास डाटा जस्ट इन पॉइंट्स है, बट वी वांट टू फाइंड आउट द रेनफॉल इन होल ऑफ द रीजन, नॉट जस्ट दो सैंपल पॉइंट। सो आप क्या करेंगे, आप इंटरपोलेशन मेथड अडॉप्ट करेंगे कोई भी दैट इज सुटेबल फॉर यू, और वो एक मैथमेटिकल फंक्शन होगा, राइट, दैट इज गोइंग टू बी मैथमेटिकल फंक्शन एंड फार्मूला, एंड दैट इज एंड दैट फंक्शन और दैट फार्मूला इज गोइंग टू give you output for different location or for whole of the region, right? So now comes our inverse distance weighting method. So your inverse distance weighting is one of the interpolation techniques. It explicitly it expli- it expli- it explicitly implements the assumption that things are close to one another, are more alike than those that are farther apart. राइट, तो ये कौन किस प्रिंसिपल पे वर्क करता है आपका इनवर्स डिस्टेंस वेटिंग मेथड की? जो चीज़ें पास हैं या जो लोकेशन पास हैं, वहाँ पर डाटा या वहाँ पर वो फिनोमिना ज़्यादा क्लोज टू होगा इंस्टेड ऑफ दोज प्लेसेस जो कि दूर हैं। आप किसी पॉइंट पे आप कोई वेरिएबल की वैल्यू निकालना चाह रहे हो, है ना, तो उस वेरिएबल का जो अमाउंट होगा, जैसे सपोज आप रेनफॉल फाइंड आउट करना चाह रहे हो किसी एक स्पेसिफिक पॉइंट पे, यू वांट टू फाइंड आउट द अमाउंट ऑफ रेनफॉल एट ए स्पेसिफिक पॉइंट। तो ये क्या जूम कर रहा है कि जो जिस पॉइंट पे आप निकालना चाह रहे हो, जिस लोकेशन पे आप रेनफॉल यू वांट टू फाइंड आउट द रेनफॉल, तो जो आपके नोन वैल्यूज हैं जो कि उसके पास हैं, जो अपनी लोकेशन है जिसपे हम फाइंड आउट करना चाह रहे हैं उसके पास हैं, वो उनसे ज़्यादा मिलती होगी जो पास है नोन डाटा, इंस्टेड ऑफ उन डाटा से जो कि दूर है, राइट। इन अदर वर्ड्स, जैसे आप सपोज यहाँ पे यू वांट टू फाइंड आउट योर रेन अमाउंट ऑफ रेनफॉल here, so what inverse distance weighting method assume that the data at this location uh, will be more similar to or will be more affected by these points that are closer to them, instead of these points these that are far away from this location, right? So it will be more affected by the values that are closer to it in spatially, right? And instead of the points that are far from it spatially. Okay, so on this premise your inverse distance weighting method works. To predict a value for any unmeasured location, IDW will use the measured value surrounding the prediction location, right? Your prediction location is the location where we want to find out the data of the variable or the value of the variable. Okay, where we want to find out the or estimate or predict the value of the variable, है ना, उसको बोलेंगे prediction location. So IDW assumes that each measured point has a local influence that diminishes with distance. Measured point means वो वाली locations जहाँ पर आपका डाटा अवेलेबल है, जैसे कि स्टेशन डाटा, आपका जो रेनफॉल का जो डाटा होगा दैट विल बी अवेलेबल ओनली फॉर द लोकेशंस जहाँ पर आपके स्टेशन है, जो स्टेशन लोकेशन है वहाँ पर आपका देयर योर डाटा विल बी अवेलेबल. सो दोज पॉइंट्स आर नोन एज मेजर्ड पॉइंट्स. ओके, दोज पॉइंट्स आर नोन एज मेजर्ड पॉइंट, जहाँ पे आपका डाटा नोन है और जहाँ पे हमने डाटा निकालना है दैट इज गोइंग टू बी नोन एज प्रिडिक्शन लोकेशन. So IDW assumes that each measured point has a local influence that diminishes with distance. तो अगर आपका measured point आपके prediction location से जितना पास होगा उसका उतना influence होगा उस measured point का, ठीक है. और जो measured point आपके prediction location से जितना दूर होगा, the more far it is, the less influence it has on the value at the prediction location. Okay, so it weights the point closer to the prediction location greater than those farther away, hence the name inverse distance weighted method. Okay, तो जैसे जैसे आपका डिस्टेंस बढ़ेगा प्रिडिक्शन लोकेशन से, है ना, वैसे वैसे आपकी वैसे वैसे इन्फ्लुएंस कम हो जाएगी आपकी प्रिडिक्शन लोकेशन पे. तो दैट इज व्हाट इज टर्म्ड एज इनवर्स डिस्टेंस वेटेड, कि जैसे जैसे डिस्टेंस बढ़ेगा तो आपकी इन्फ्लुएंस कम होगी. तो इन्फ्लुएंस या वेट, इन्फ्लुएंस वी आर रिप्रेजेंटिंग और वी आर yeah, we are representing the influence by the weight that is going to be given to a particular measured point. ओके, तो जैसे जैसे आपका ये जो मेजर्ड पॉइंट का डिस्टेंस प्रिडिक्शन लोकेशन से दूर होगा उसको वेट कम दिया जाएगा. वाई? बिकॉज उसका इन्फ्लुएंस कम होती जाएगी. सो मोर डिस्टेंस less influence. So that is why, so there is the inverse relationship between your weight and distance, right? So that is why it is known as inverse distance method. So the formula for inverse distance method to find out the value of the variable at a prediction location, using the measured point value at the measured points is this. Okay, so IDW is given by your ZZ equal to summation of ZI divided by Nij divided by summation of 1 by Nij, where Zi is the value of known point and Di, Dij is the distance to known point. Zj is the unknown point. N is a user selected exponent. Okay, तो जो पावर है ये जो n है that is going to be selected by user. ये 1 भी हो सकती है 2 भी हो सकती है, but we will do with n equal to 1, the most basic one. Okay, so suppose let us clear it with a example. So यहाँ पे जो आप this middle point, this cross is your prediction location where you want to find out the value of a particular variable. That variable could be uh, your rainfall, your temperature, right? But suppose here we are talking about temperature. So we want, so here variable is temperature. So this point is the point where the value of temperature is unknown. Okay, and we want to find out the value of temperature at this point. So this point is going to be known as prediction location, right? And these are the points or these are the stations where the value of temperature are known. So these are going to be known as your measured location or measured points, right? So we, to find out the value at this point, we are adopting inverse distance weighting method. So what do we do in inverse distance weighting method? Firstly, we have to find out the distance of each uh, measured point from the prediction location. Okay, we have to find out the each distance of each measured point these black dots, these round dots are your measured points. Okay, so we have to find out the distance of each measured point from your prediction location. So here you can see d1 is 4 meter, d2 is 2 meter, and this d3 is 6 meter. So what does your inverse distance weighting method tell us? It tells us that more closer a measured location is to the prediction location, more influence it will have. So most influence on this prediction location will be of this measured point. Okay, क्योंकि इसका distance सबसे कम है. Here distance is only 2 meter. Here it is 4 meter. Here it is 6 meter. So the least distance out of these three is this d2. So ये जो आपका measured point है यहाँ पे 30, इसकी सबसे ज़्यादा influence होगी इस पे, right? And then comes your 50, इसकी second number पे होगी, and third number पे इसकी होगी. So we are going to assign weight to each value depending upon its influence. ठीक है, सबसे ज़्यादा इन्फ्लुएंस किसके, 30 वाले की, फिर 50 की, फिर 52 की. इसकी सबसे ज़्यादा इन्फ्लुएंस क्यों है, क्योंकि इसमें डिस्टेंस कम है, राइट? तो हम इनको इसको इन पॉइंट्स को वी आर गोइंग टू असाइन द वेट अकॉर्डिंग टू देयर इन्फ्लुएंस. एंड हाउ डू वी असाइन वेट? We assign weight according to its distance. So more the distance between these 2 points, okay, the less influence it will have. So influence will be 1 by distance. Okay, influence or weightage given to each measured point is going to be 1 by distance. So as your distance increases, your weightage will decrease. Okay, so here you can see 50 is the value, measured value at this point, this known point, and its weightage is given how much? 1 by 4, 1 by inverse of distance. Okay, weightage is given equal to inverse of distance. What is inverse of distance here? 1 by 4. So 50 into 1 by 4, then 30 into 1 by 2, then 52 into 1 by 6. Okay, divided by what? Divided by your all the weightage that were given, summation of all the weightage that were assigned to these points. Okay, so 1 by 4 plus 1 by 2 plus 1 by 6. So that is going to give you the value of the variable at this unknown point, okay, or at this prediction location. So this is what this is, zi divided by dn. Okay, so what is that? Z is the value of the variable, and dij is the distance between the prediction location and the measured point. Okay, so d here, d 4 2 6, these are the d's. This is the distance between your prediction location and your measured point, right? And here you can see we have assigned n equal to 1. We can also assign n equal to 2, n equal to 3, but mostly you will see n equal to 2 and n equal to 1. It depends upon the user that is using this inverse distance weighting method. Okay, कि आपने n की वैल्यू पावर कितनी देनी है. यहाँ पर n की वैल्यू 1 है, that is why यहाँ पर just 4 है, just 2 है और 6 है. If it was n equal to 2, then here weightage was going to be weightage were in that case would be 4 raised to power 2, 2 raised to power 2, 6 raised to power 2. Okay, here same 4 raised to power 2, 1 by 2 raised to power 2, 1 by 6, 2 raised to power 2. If we uh, if we would took n equal to 2, but in this example we have taken n equal to 1. So this is how you will find out the distance using IDW method. So what is the advantage of using IDW method? It is most easily understood. It is it is intuitive, right? आपको आसानी से समझ आ जाता है, क्योंकि ये तो बेसिक मतलब इंट्यूटिव है कि जो पॉइंट जितना दूर होगा उसकी इन्फ्लुएंस उतनी कम होगी, जो पॉइंट जितना पास होगा उसकी इन्फ्लुएंस उतनी ज़्यादा होगी। एंड ऑन दिस प्रीमाइस दिस इंटरपोलेशन मेथड वर्क। तो ये easy to understand and will not produce estimated values outside measurement, right? Outside measurement means आपके जो वैल्यू होगी यहाँ पे एस्टिमेट, इससे बाहर नहीं जाएगी। जो सबसे छोटी है, सबसे छोटी कौन है 30, और सबसे बड़ी कौन है यहाँ पे 52। तो आपकी जो योर कैलकुलेटेड वैल्यू, योर एस्टिमेटेड वैल्यू विल नॉट गो आउटसाइड दिस रेंज। 30 से छोटी नहीं होगी, 52 से बड़ी नहीं होगी। ओके, दैट इज गोइंग टू बी इट्स एडवांटेज। Now, what are the disadvantage of using IDW method? That no assessment of prediction error. You cannot predict how much error we can expect from the result. Okay, so no assessment of prediction error. Produces bull's eye around data location. Okay, produces bull's eye means bull's eye देखा आपने, concentric circle जैसे बना देगी ये, concentric circle. Okay. The best result from IDW are obtained when sampling is sufficiently dense with regard to local variation you are attempting to simulate. Okay, so when you have relatively dense data population, okay, sample data that you have uh, value known, so when it is dense, then it is going to give you relatively accurate or good results. Okay, if the sampling of input points is sparse or uneven, the result may not sufficiently represent the desired surface, right? So अगर आपका डाटा स्पार्स है, आपके जो लोकेशन मेजर्ड पॉइंट है, आपके जो जहाँ पे आपकी लोकेशन, जहाँ पे आपकी वैल्यू नोन है जिन लोकेशन पे, राइट, दोज आर नोन एज मेजर्ड पॉइंट। तो अगर आपके मेजर्ड पॉइंट दूर दूर है और अनइवन है, मीन्स किसी एक साइड उसका इकट्ठा बड़े सारे डेंस हैं और बाकी एरिया में बहुत स्पार्स है, बड़े दूर दूर, so in that case it is not going to give you very much accurate result. Okay, then what are the factors that are affecting the interpolated surface in IDW? Size of exponent, that is n. Okay, यहाँ पे जो in the example we used n equal to 1, right? But अगर हम n equal to 2 लेते तो यहाँ पर क्या होना था, जो आपकी वेट दिए 1/4, 1/2, 1/6, these are the weights. These will have power n equal to 2, n equal to 3. Okay, but here in this example, in the previous example, we used n equal to 1. Okay, so factor affecting the interpolated surface, size of exponent n affects the shape of a surface. Larger n means the closer points are more influential. Okay, तो अगर n का साइज, अगर n का आपका n अगर आपकी वैल्यू ज़्यादा होगी, यानी कि n equal to 2, n equal to 3, so that would mean that जो आपके पास वाले जो पॉइंट्स हैं, द मोर इन्फ्लुएंस दे विल हैव, है ना, as compared to the points that are farther away. Okay, तो जितनी ज़्यादा आपकी n की वैल्यू बढ़ेगी, उसका क्या मतलब हुआ कि जो जितने पास पॉइंट है उनका इन्फ्लुएंस उतना ज़्यादा और इंक्रीज हो जाएगा। ठीक है, लार्जर नंबर ऑफ सैम्पल पॉइंट्स रिजल्ट इन स्मूदर सरफेस। ओके, तो अगर आपके पास जितना ज़्यादा सैम्पल पॉइंट्स होंगे आपके, उतना आपका स्मूथ सरफेस होगा। Now let us compare the IDW method with the other techniques. How your IDW method is different from the other interpolation methods. So a surface created with IDW will not exceed the known value range or pass through any of the sample points. IDW is a good interpolator for phenomena whose distribution is strongly correlated with distance, right? So the value that you will get uh, the value that you will get using the IDW method will not exceed the two extremes, or it will not go beyond the two extremes. It will not be lower than the lowest value, no lowest input value, and it will not be higher than the highest input value. It will be it will be in between. And the surface created with spline. So spline is your different interpolation method. So a surface created with spline can exceed the known value range. but must pass through all of the sample points, right? So in spline method, you can have calculated value or estimated value that that could be exceeding the highest value in the input. Okay, and in spline method, your interpolated surface will be passing through all of the input points, right? Whereas in kriging, it is one of the most complex interpolator, and it measures the relationship between all of the sample points and then predicts the cell value. A surface created with kriging can exceed the known value range. So similarly to that of spline, in kriging also the calculated value or the predicted value can be higher than the highest input value, and right. But how it does it different from from spline is that it in kriging your estimated surface, uh, it is not necessary to pass the pass the uh, interpolated surface through all of the sample points, through any of the sample points. Okay, so let us do a recap and do another numerical example to clear this method. So, as the definition goes, inverse distance weighting method or IDW interpolation estimate the unknown values with specifying search distance, closest points, power setting, and barriers. Okay, so these red ones here in this diagram are representing the location with known values of a variable. Here, variable is height, right? You can see uh, there are elevation differences in this diagram. So these red points are locating the points where the value of the elevations are known, and we have to find out the value of elevation at this location, at this blue point, right? So what points to include, what point will be included in the input can be can be uh, determined by using a circle or a search radius or by some barrier. Okay, so it does provide some, it does provide us flexibility to include the inputs, how much of the known points or how much of the known points we can include in our calculation of inverse or IDW interpolation method. Okay, so to do this, to find out the IDW, you start with known values and you estimate the unknown points through interpolation. IDW interpolation is mathematical or deterministic, assuming closer values are more related than the further values with its function, right? So while good, if your data is dense and evenly spaced, let's look at how IDW works and where it works best. So has already been discussed, IDW work best when you have when you do not when your data point is relatively denser, when your samples are relatively denser and are evenly spaced, then your IDW work best. Okay, so we can estimate the value of a variable at a known location. Unknown location means location where the value of that variable is unknown by using the values at the neighboring points, the known values at the neighboring points as the input, right? So near points are more alike than far points, right? So on this premise, your IDW work that the, the points that are near to your prediction location will have more effect or more influence, right? For example, noise is louder closer to a siren than further away, right? So influence or the effect of noise will be more when it is closer to a particular or observer location, right? Similarly, influence of influence will be more. from the locations that are closer to your prediction location, or the location where we want to find out the value of a variable, right? So when another example is when it's raining, it's more likely to rain 1 meter away compared to 500 meter away, right? These are examples of spatial autocorrelation. You so here Tobler's first law of geography. Okay, so these are the example of spatial correlation, or Tobler's first law of geography, that certain phenomena are spatially correlated or geographically correlated. The more distance 2 point are, the more less likely sorry the less likely they will be close to each other or have closer value. The closer they are spatially, 2 points, the closer they are spatially, it is more likely then it's more likely that they have approximately relatively similar values. Okay, so this spatial autocorrelation is the underlying assumptions of your IDW method. So you can see in this example below, we can choose how many points to take as the input. Here we only taking these 3 points as the input. Okay, so in this example below, the red points have known elevation values. The other point by this violet color will be interpolated. Here the value of elevation, or here variable is elevation. Okay, so the value of variable or elevation is unknown. If you want to measure the purple point, you can set up a interpolation so that it takes a specified number of location as the input, right? So you can set up by choosing a certain radius of influence. Okay, so you can see how IW, so this is very flexible method IDW. You can choose how many point to take as the input, right? So specify your search radius, and your interpolation will only use the number of known points within your search radius, right? So if we are choosing only this search radius, only one input point is going to be there, right? Now we can also tweak or modify our result if we change the exponent or the power or the value of n in the LW formula, right? So interpolated points are estimated. So you will see in the next diagram that interpolated points are estimated based on their distance from known cell values. Points that are closer to known values will be more influenced than the points that are farther away. So you can see when we have a power or exponent equal to 1, n equal to 1, it will create this type of surface, right? It will smooth out your interpolated surface. And when we increase the power or exponent in the formula for IDW, the overall influence it has from the uh, known value will increase, right? So you can see how the peaks and the values are more localized and are not averaged out as much as the power of 1, right? So here, the more closer the point are, more effect or more influence they will have at a particular relation, at a particular location, as compared to the case when n was equal to 1, right? So closer location will have more influence on your prediction location when your power is increased. Okay, so how do we how did we find out the value at our prediction location, here denoted by this violet ball, a violet dot? So you just find out the distance between your input locations and your prediction location, right? So distance, you can see distance of this 12 from your violet is 350 meter, and then this location from your violet location is 750 meter, and from here to here it is 850 meter, right? So what was the formula? If you remember, we would uh, provide weight to each input according to its weight, right? So inverse of the weight will be provided as the input, and we can modify that weight by choosing the exponent or power, by choosing the value of n. Okay, so here for power 1 it would simply be like this, right? So it is coming out to be 11.1, and when we are choosing power or n equal to 2, that's how we are going to do. And in this comparison our value is 11.4. Okay, so we did that, this and this is this and this. Here we are using this formula, right, that we have done earlier. So I hope you did understand uh, how IDW works and how to find out the IDW. Conclusion is that there are different methods of interpolation. Choosing an interpolation method is influenced by your knowledge and the surface you are modeling. Each method works differently, but most utilize the concept of spatial autocorrelation, right? So near things are more alike than things far away. So almost every other spatial interpolation method use this premise. The IW method is helpful to create a surface from which we can know how much area is being influenced. But if we consider point data, we cannot find the influenced area. So we can use this technique. Okay, so that's it for today. We will discuss other interpolation method in our next session.